Hello students, this is Unit 4, Lesson 1. We are going to be talking about rational expressions in this lesson. We hope to be able to simplify, multiply, and divide rational expressions by the end of the lesson. So let's review what rational numbers are. A rational number is any number that can be written as a fraction. We know that this can be simplified. We could divide by 2, divide both of them by 2. But let's talk about the simplification process and what we would do. So I could rewrite 12 as 2 times 2 times 3, and I could rewrite 18 as 2 times 3 times 3. So then looking at the factors, because these are multiplied times each other, what I could do is I could cancel out some pairs of factors. So the 2 divided by 2 equals 1, so I can just mark those out and say I'm just dividing each of those by 2. And then there's a set of 3's over here that I could also cancel out. And then what I have left in the numerator is a 2, and then what I have left in the denominator is a 3. So the simplified version of 12/18 would be 2/3. Obviously, we just look at this and we say, okay, I'm going to divide both of these by 6, and divide by 6 up here, divide by 6 down here. It's not so easy with expressions with variables and everything in it. So we need to really think about the fact that we actually look for common factors in the numerator and denominator, and we can cancel those out. But the first thing we have to do is factor each of these rational expressions before we can start canceling out. Don't confuse simplest form with changing an improper fraction to a mixed number. I could have a fraction like 4/3. This is simplest form. It's an improper fraction, but I don't need to change this to 1 1/3. Most of our exams at the end of the year allow you to leave these in improper fraction form, and that is what I prefer and what most teachers at a higher level would prefer as well. So don't confuse this with this is not simplest form. This is simplest form. This is just an improper fraction. It's not a mixed number, but we don't have to change it to a mixed number for it to be simplest form. So keep in mind as we go on to the next page that simplest form means the greatest common factor, or GCF as we call it, of the numerator and denominator is 1. So one other thing to keep in mind as we work is that in a fraction, the denominator cannot be 0. So we want to make sure that we look for that as we work. So denominator, might want to write that down, cannot equal 0, because we know that if a denominator is 0, the answer would be undefined. We can't divide a number into 0 groups. That's why we can't have a denominator that equals 0, because this fraction bar means divide. So these are your steps for simplifying rational expressions. We're going to start looking at expressions with variables in them on the next slide. You can pause this and write this down, and as we go through, we'll talk about the steps again and make sure that they make sense. They might not make sense now, especially number 4, but we'll talk about that as we go through. So just a reminder, if you are one of my students watching this video, your notes are going to be on plain paper, so you can take them on notebook paper or on plain copy paper, because there aren't any guided notes for this unit. Okay, so let's look at this problem. We are instructed to simplify this problem, and of course with the 12/18 when we looked at that, it was, oh yeah, just divide by 6. The GCF is 6. Well, it's not so easy when you have expressions with variables. Our factoring skills are going to get a workout in this lesson, I guarantee you. So what was the first thing it said in our steps? It says factor GCF first. Well, that means find if there's a GCF, or greatest common factor, for x squared and -25, we want to factor that out first. Well, obviously there isn't. I mean, there is, it's 1. But if it's anything other than 1, we want to factor that out. Same thing for the bottom. If all of these were like divisible by 2, we would take that 2 out first. We don't have that in this case. So the next thing we do is we factor the numerator and we factor the denominator. The numerator, I have an x squared and I have a 25. Both of these are perfect squares, and so I know that I can factor these into 2 binomials, take the square root of x squared, which is x, that's my first term, take the square root of 25, which is 5, and then I would have a plus in one parentheses and a minus in the other. If I multiply that back out, my middle terms, my 5x and -5x would cancel out, and so that's why I don't have a middle term here for this quadratic. The bottom quadratic, I know that I should be able to factor this, and most of the ones you get, you're not going to be using quadratic formula. Thank goodness you don't have to do that, because the point here is to simplify these. So let's look at this one. We need two numbers that when we multiply, we get -10, and then when we combine them, we get -3. That's going to be x minus 5 and x plus 2. So now we are at the point where we can cancel out like factors in the numerator and denominator. And I see I have an x minus 5 here and an x minus 5 here. So what I can do is just mark them out. Just cancel them out. And then my answer is going to be x plus 5, because I don't have anything else I can cancel out, over x plus 2. Now, the last thing I want to do is I want to go back and look at these factors in the denominator. So once I've factored the denominator, I can figure out what x cannot equal. The way I do that is I set up each of these equal to 0. So x minus 5 equals 0, and I solve for x. X cannot equal 5. X plus 2 equals 0. X cannot equal -2. So these are the domain restrictions. That's what we call that. And you do that at the point where you've factored both of them. Think about it. If x equaled 5, let's look at what this denominator would be. If x equaled 5, this would be 25 minus 3 times 5 is 15 minus 10. 25 minus 15 minus 10, that's 0. It can't be 0. So that means x cannot equal 5. So wherever you get your denominator factored, that's where you can figure out what those domain restrictions are. You can do that at this point where you factored, do that there, or you can wait until after you finish and then go back to the factored form and figure it out. So what we would say is, this is the answer, this right here equals this, but only where x does not equal 5 or -2. So these are the restrictions. This is what has to be true for this expression to equal this expression. So of course it says in our steps that, state any restrictions on the domain, set each factor in the denominator equal to 0. Okay, I'm going to speed it up a little bit. Here's another one. The numerator has a GCF, so we're going to pull that out first. We're going to take out a 2. And when we do that, remember that's opposite of distributive property. So let's divide this by 2, get x squared. Divide -10x by 2, 5x. This one is going to be -14. And in the denominator, I can divide both of these terms by 3x. So I'm going to take out a 3x. That will leave x minus 7 in parentheses. I'm not finished factoring yet. I still have to factor this trinomial up here. So everything else, I'm just going to bring it over. Can't factor anything else in my denominator. So let's factor this trinomial. That's going to be x minus 7, x plus 2. Okay, so at this point, we could state our domain restrictions, which I'm going to go ahead and do. So this is a factor right here. This is a factor. 3x equals 0, divide by 3. X cannot equal 0. And then x minus 7 equals 0. X cannot equal 7. So these are the domain restrictions, so you can't have either one of those happening. But I can cancel out the x minus 7. I believe that's all I can cancel out on this one. So everything else just stays the same. And you can leave it in factored form. You don't have to multiply that 2 back in or anything. 2 times x plus 2 over 3x is the solution, or is the simplified version of this. So this equals this as long as x does not equal 0 or 7. Multiplying rational numbers. So these are your steps. Factor, Gcf first, cancel out like factors. Same thing we've been doing. But when we multiply two fractions, we just multiply straight across. I like to simplify and cancel out stuff before I multiply. Because if I were to multiply this 12 times 3 and then 18 times 4 and then try to simplify that, to me that's a lot more difficult than simplifying in the first place. Simplify coefficients and then state any restrictions, the same thing we've been doing. So if I'm looking at these two fractions right here and I want to multiply these, I'm going to look for places that I can simplify. Well, I can simplify the 12/18ths, or I can cross simplify. If I have a numerator and a denominator with something in common, then I can also cancel out there. So if I think about 18 and 3, I can divide both of those by 3. So I would divide by 3 here, and then divide by 3 here, Okay, and then I think about 12 and 4. I can divide both of those by 4, divide by 4, divide by 4. Now what I have left over is a 3 and a 6. I can also simplify there. I can divide both of those by 3, so you can simplify a second time on these. Divide by 3 there and there. And my answer is, the only thing I have left in my numerator is a 1. So anytime you cross out everything in your numerator, you have a 1 left over, and then my denominator is 2. So 12/18 times 3/4 is 1/2. All right, let's look at some expressions. So there are really several ways that we can work these. We can write this as one big numerator and one big denominator. We can just understand that anything that I can cross cancel out, as long as there's something in the numerator and something in the denominator that are in common, I can cancel those out. It doesn't have to be in the same fraction. So what I'm going to do is I'm going to rewrite this, and I'm going to just factor everything. So 7m cannot be factored. I just have to rewrite that 7m. 3m plus 21, I can take out a 3. 2m plus 14, I can take out a 2. And then 9m cannot be factored. Okay, so now at this point I have everything factored, and again we're going to state domain restrictions in the denominator. So if we want to do that, we're going to do m plus 7 equals 0, so m cannot equal 7. And then 9m equals 0. So m can also not equal 0. All right, so then what we can do is look at these and start canceling stuff out. Well, I see I have an m plus 7. One's in a numerator and one's in a denominator, so I can cross those out. What else can I cross out? I can actually cross out this m and this m. I do see something else. I can cancel the 3 and the 9. So I do want to simplify coefficients before I go any further as well. The 3 and the 9, I can divide both of those by 3. Divide 3 by 3 and 9 divided by 3. All right, I think I've got everything here. I don't have any variables left. I have a 7 in the numerator and a 2 and a 3 in the denominator. So now what I do is I bring that 7 over and I multiply the 2 times the 3. So the answer to this is simplified this times this. So I need to state that my answer is 7/6 as long as m does not equal 7 or 0. Okay, my next problem, the only thing I see that I can factor is this right here, but I like to rewrite everything. It just, to me, it makes it easier to kind of keep up with everything. 4x squared can't be factored, x minus 2 can't be factored, the 12 is just 12. This is difference of two squares, so this is going to be x plus 2, x minus 2. Now, what can I cancel out? Before I start canceling, I want to just make sure I look at my denominator and state, okay, x minus 2 can't be 0, so x cannot be 2. So that's my domain restriction that I'll state at the end. Let's see, I can cancel out an x minus 2. I can also do the 4 and the 12, divide those by 4. I think that's all I can cancel, so let's just rewrite this, x squared times x plus 2. And again, you can leave this in factored form. You don't have to multiply that through or anything. And then in the denominator, all I have left over is the 3. So this is my answer as long as x does not equal 2. Okay, so for this next one, I would encourage you to pause your video and see if you can factor this and then come back and look and see if you got the factors correct. Okay, so this is what you should have gotten after you factored the numerators and denominators. I want you to keep in mind, you cannot cross out anything until you have factored everything. Like these x squares right here, I have students a lot of times who will try to go ahead and cross those out. You can't cross those out. You can't cancel the 4x and the 2x. You have to factor everything first and then see what factors they have in common. Okay, so let's start looking at our domain restriction. X plus 4 cannot equal 0, so x cannot equal negative 4. X cannot equal 4. And x cannot equal negative 5. Okay, so let's cancel some stuff out. This is the fun part to me. X minus 4 can cancel. X plus 5 can cancel. And I think that's it. I've got an x. Yep. So everything in the in the numerator multiply. And then the denominator is 2 times x plus 4. So this is our answer as long as these things do not occur. Okay, I think this is the last one in this section on multiplying. I would encourage you again to pause the video and then come back and see if you factored it correctly. So these are what your factored forms look like, and we'll go ahead and do the domain restriction. X cannot equal 4. X cannot equal negative 2. This would be 3/2. And then the last one would be negative 1. So x can't equal any of these. Let's go ahead and start canceling. I see an x minus 4, a 2x minus 3, an x plus 2, and an x plus 1. So guess what? We only have 1 in the numerator and 1 in the denominator. So x would equal 1. This simplified, or just multiplied and simplified, would equal 1 as long as your x's don't equal any of these. Okay, so we're going to get through division as quickly as we can. The first thing I want you to remember is when you divide by a fraction, you need to multiply times the reciprocal. Remember that keep, change, flip you learned a long time ago. So we need to rewrite our first fraction as it is, change this to times, and then flip the second number, which is what we're going to do with the expressions as well. The biggest thing that we need to remember is the restrictions on the domain, and I'll talk about that in a minute. But if we were going to divide this, we could simplify first after we change it to a division problem. This is 2 and 9, divide by 3. And then I think that's all we can do here. That's going to be 8/9. All right, so domain restrictions, where you have two fractions that one of them is divided by another one. You have A here, B here, C here, D here. The only one that we don't check for domain restrictions is the numerator of the first fraction. And I'm going to talk to you about why. Let's look at an example first. So here's an example. If I have the division problem, just the division problem, I need to look at domain restrictions for this denominator right here, just like I always do. But I also need to look for domain restrictions on this denominator, because if this denominator were 0, I can't divide by an undefined term. So I have to check this one for domain restrictions. But then when I flip it, this becomes the denominator. So that's why I have to also check this one for domain restrictions. So all three of these expressions have to be checked for domain restrictions. The only one that you don't have to check is this one. So I highlighted the three that need to be checked, and now I'm going to go ahead and rewrite this as a multiplication problem before I start factoring. I think it's easier to rewrite it first as multiplication. So this denominator becomes the numerator over here, and this numerator becomes the denominator. So I'm going to highlight again. I still am checking this one, and this one. So the second fraction, you're going to check the numerator and denominator for your excluded values or domain restrictions. Now we can factor. I have a difference of 2 squares right here. I have an x I can pull out here. This is also a difference of 2 squares, so I can squeeze this in. And this one's just x minus 3. Okay, so now I need to check this denominator, and this numerator for my excluded values. X cannot equal 0, because this would be x equals 0. X plus 1 cannot equal 0, so it can't equal negative 1. It can't equal, let's go up here, that's my negative 1. It also can't equal 1. And then down here, it cannot equal 3. So there's my domain restrictions. Now I can just start canceling stuff out. I got an x minus 3 here. I have an x plus 1 there. I think that's it. So let's go with everything that's left over. And then I only have an x in the denominator. So this right here equals this if x does not equal 0, negative 1, 1, or 3. So this lesson really has gone over the time limit I like to set, but there's a lot in this lesson, so I do want to go over enough problems with you. This is your next problem. Again, rewrite it as multiplication and then factor. So I want you to try this one and then come back and see if you got the answer correct. Okay, so here's what I got. 3 times x minus 1 divided by 3 times x plus 1. X cannot equal 0, -1, or 1. I wanted to just point out that you could cancel out the x here and an x from this x squared. So I divided both of those by x, the 3x and the x squared. Okay, I have 2 more problems for you. I especially wanted to look at this one with you because this is what we call a complex fraction. This is a fraction divided by a fraction. This big fraction bar just means divide. So it's really the same thing we've been doing. It's just that they've written it as a complex fraction instead of a division problem. So I'm going to rewrite this as a division problem. So because this is a division problem, I would strongly recommend that you don't try to skip steps on this. I would really think that it's important to rewrite it as a division problem first, identify everything that you're going to have to look at for domain restrictions, which are all 3 of these, then rewrite it as a multiplication problem. So I've rewritten it as a multiplication problem here. And one thing you could do is if you see where you can factor these, like I know this is difference of 2 squares, I could go ahead and factor that as I go. I can take out GCFs as I go. So you could skip a step there, but I would not skip this step and this step. I would write everything out. So I'm going to go ahead and factor these and finish this out, and then you pause your video and see if you can do it and then come back. Okay, so this is factored here. I'm going to go ahead and do my domain restrictions. X cannot equal 2. I'll do this up here. X cannot equal 2. This one's also 2, so that's fine. It cannot equal -3 or 3. And again, I'm just taking each of these factors and I'm setting them equal to 0. So that's what it can't equal because we can't have a 0 in any of those places for it to be true. Let's go ahead and cancel some stuff out. Cross out the x minus 2s, the x minus 3s. That's all I can do there. So we're going to multiply the 3 times the 4. 3x times 4, that's 12x. And then in the denominator, all we have left is x plus 3. So it equals this as long as x does not equal 2, -3, or 3. So in this video, you learned how to simplify, multiply, and divide rational expressions. Rational expressions are fractions that have polynomials in the numerator and denominator. You learned that you have to factor stuff first before you can cancel out anything. Also, you have to cancel complete factors like this x minus 4. You can't cancel these x's. You have to cancel the whole factor if you're going to cancel it. So factor first, take out GCFs, and then factor everything, then start canceling stuff out in the numerator and denominator. You also learned about excluded values, which are restrictions on the rational expression. You can't have a denominator equal to 0. So you set the factors in the denominator equal to 0 and figure out what those are. And then you state your answer, but then you state, okay, yeah, it's this answer, but x cannot equal these excluded values.